For example 2, we have quite a bit in the directions. We're supposed to determine if the graph opens upward or downward. We're supposed to find the axis of symmetry, the vertex, the y-intercept, and the graph. And there is a little hint here. We are supposed to use x is equal to the opposite of b over 2a in order for us to go through and do our graph and our calculations with our vertex. So for letter A, here is our equation. If you're going to do this the fast way, you would want to identify where the vertex is. If this were in vertex form, like letter A was, we could just look at the equation and write it down, but this is not vertex form. We just have an x squared term, an x term, and a plain old number. And what that means is that we have right now something in standard form. Standard form of a polynomial is written in this form, and we have a polynomial here, specifically a quadratic. Highest power of x is first, and then descending order of power, they get smaller. The powers of x get smaller as you go downward. So we need a fast method, since we don't have this in vertex form, to go through and find the vertex. Before we do that, let's determine whether this graph is going to open upward or downward. In example 1, a was a negative 1/2, and we know in that form that if your value for a is a negative, it's going to open downward. If it's positive, it's going to open upward. Your standard form for quadratics is the form y equals ax squared plus bx plus c. That's where we get the a and the b and the c when we go through and do the quadratic formula. So a in this problem happens to be 2. And because a is positive, that tells me that our graph is going to open upward. So one of the things that we need to do is we need to identify whether the graph opens upward or downward. And in standard form or in vertex form, that's easy to do. This first number here is going to be our value for a, and it's the same rule for both. If it's positive, like it is here, it's going to open upward. If a is negative, then our parabola is going to open downward. I did mention that a and b and c are the 3 numbers, the coefficients in front of each of those terms. So a is equal to 2, b is going to be equal to a negative 4 because of the subtract 4x, and then c in this problem is equal to a positive 5. The first part of the directions, we identified this graph as opening upward. We also need to find the axis of symmetry and the vertex, and we'll find the vertex next. To find the vertex, this is what we are going to go through and use. It says here we should use x is equal to the opposite of b over 2a. The x-coordinate of your vertex can be calculated by doing the opposite of b over 2a. So looking at what we have in this problem, a is equal to 2, and I could put that down in the bottom, and b is equal to a negative 4. So for this problem, what we would have is we would have the opposite of b, which would be the opposite of negative 4, over 2 times a, which would be 2 times 2. The opposite of negative 4 is 4. 2 times 2 is 4. So the x-coordinate of our vertex is 1. Or if I say it another way, our vertex is the point 1 comma something. I just need to figure out what that something is. So vertex is 1 comma, and then there's a y-coordinate there that we're going to need to figure out. But we'll figure out the y-coordinate how we usually do. To figure out the y-coordinate here, we're just going to take our value for x and plug that back into the equation. So we're going to calculate f of 1. We're going to take 1 and plug it into the original equation. That is 2 times 1 squared minus 4 times 1 plus 5. 1 squared is 1 times 2 is 2. 4 times 1 is 4. So 2 minus 4 is negative 2. Plus 5 is 3. So when we plugged in 1 for x, we got 3 out for y. So that means our vertex is the point 1 comma 3. So that is a fast way of finding the vertex. The x-coordinate of your vertex can be found by calculating the opposite of b over 2a, and then take that number that you get and plug it into the original to find the corresponding y value. Now that we know where the vertex is at 1, 3, we can use the idea from this example to come up with our equation. In this problem, the vertex was at negative 5, 8. The axis of symmetry is always going to be a vertical line for these parabolas that we're looking at. The form of that vertical line is always going to be x is equal to a number, specifically the x-coordinate of the vertex. So the axis of symmetry in this problem is going to be x is equal to whatever the x-coordinate is of our vertex, and we calculated that here earlier. It was the number 1. So x equals 1, that is the equation for our axis of symmetry. We have our vertex here. Our vertex is the point 1, 3, and we know our graph opens upward. We're also supposed to find the y-intercept. Anytime that you go through and you find a y-intercept, you plug in 0 for x. Anytime you're finding any intercept, you plug 0 in for the other variable. So if you're finding a y-intercept, you're going to plug 0 in for x. If you're plugging in 0 for x into your equation, that's like calculating f of 0, which would be 2 times 0 squared minus 4 times 0 plus 5, which is just equal to 5. So we just plugged in 0 for x, and we got 5 out for y. And that is going to be our y-intercept. All right, in the directions, we're supposed to determine if it opens upward or downward, find the axis of symmetry. Typically, you find the vertex first, then the axis of symmetry, and the y-intercept. So we've done everything except for graph. To finish this problem up and to finish the graph, you can do this a few different ways. We have a couple of points here. We do know the vertex is at 1, 3, and we do have a y-intercept at 0, 5. So I could put those points in. There's 1, 3, there's our vertex, and I could put in 0, 5 also. The axis of symmetry does go through the vertex, so if you wanted to put that in, it would be a vertical line that goes through the vertex. And then you can use that to find more points. This point right here, the y-intercept at 0, 5, it is 1 unit over from our line of symmetry, so we could go 1 unit over to the right and get another point in there. Otherwise, here's really the faster way to do this. Just put the vertex in, and then come back and look at your value for a. So if I graph the vertex at 1, 3, and I know that a is 2, it's a positive number, so our graph opens upward. And to get more points, that means that our graph is twice as steep. Remember, this a that we have in front of the x squared term here in standard form is the same as the a that's in front in vertex form, and that tells us how steep the graph is. So this graph is going to be twice as steep. So you could go through and plot some points like we did there. Otherwise, you can go back to the idea of this. Go to your vertex, go over 1, and normally we would go up 1, but because a is equal to 2, that means our graph is going to be twice as steep. So instead of going over 1 and up 2, instead of going over 1 and up 1, we need it to be twice as steep. So we'd go over 1 and up 2 on both sides, which is another way to get those points. Then going back to the vertex, we could go over 2 and up 4, but we have to make the graph twice as steep, so we'd go over 2 and up 8. So over 2 and then up 8. Just off the top of my graph. Go back to the vertex, over 2 and up 8 on the other side, and then you end up with your U-shaped graph. So that's the faster way to go through and do that. But remember, all of that is just a shortcut to making an XY table. You could always make an XY table, plug in some numbers, and come up with some more points. All right, let's run through and do this next example following those same directions. First, I want to identify if this opens upward or downward. In this problem, I can see that a is going to be a -1, and that b in standard form here is going to be a -2. We don't really use c, but for any of the formulas at least. But c is 3 in this problem. And once I know that, I can just look at a and see if it's positive or negative and determine if our graph opens upward or downward. In this case, it is going to open downward. So there's our first thing. Then from there, we're going to calculate our vertex. And in standard form, to find the x-coordinate of the vertex, we use that x-coordinate is equal to the opposite of b over 2a, and we plug those numbers in. So for this problem, it would be the opposite of negative 2 over 2 times negative 1, which would give me 2 over negative 2, or a negative 1. And now to calculate our vertex, we have the x-coordinate. It is a negative 1. To calculate the y-coordinate, we just would want to plug negative 1 into the original equation. So we'd calculate f of negative 1, which would be the opposite of negative 1 squared, minus 2 times a negative 1 plus 3. Negative 1 in parentheses squared is 1, but then we have a negative in front, so that gives us a negative 1. Negative 1 times 2, negative 2 is positive 2, so we have negative 1 plus 2, which is 1, plus 3 more, which is 4. So negative 1, 4 is the location of our vertex. And now we know where the axis of symmetry is pretty easily. Our axis of symmetry is always x is equal to a number, and specifically it's the x-coordinate of the vertex, and the x-coordinate of the vertex was at negative 1. We're supposed to find the y-intercept. Anytime you find the y-intercept, you plug 0 in for x, so you're going to calculate f of 0 and plug that in. In standard form, you're plugging 0 in for these x's, so you're always going to end up with just that value for c on the end, so it is going to be 3, but if we were going to show a little work with that, we'd plug in 0 for each one of the x's that are there, and a lot of those terms cancel out. We do just get 3. So our y-intercept is at the point 0, 3. Last thing we need to do is graph. And the graph you can do two ways. Here's how I would do it. This would be the fast way. Graph your vertex. That's at negative 1, positive 4. And then from there, I would use that value for a to get the rest of the graph. A in this problem is negative 1. It's negative, so our parabola is going to open downward. And the numeric value is 1, which means it's exactly the same steepness as the parent function. So the parent function goes over 1 up 1, and then over 2 up 4 from the vertex. For this one, all we need to do is go downward, but the steepness will be the same. So from our vertex, I'm going to go over to the right or to the left 1, and then instead of going up 1, I'm going to go down 1, so our parabola can open downward. Then I go back to the vertex, and then I go over 2, and then down 4. Oops. That point should be there. I went over too far. So not this one. So our graph should look like that. Same steepness as the parent function, and it opens downward with the vertex at negative 1, 4.